Moving along here to problem number 25, we're going to try to factor this trinomial. Nothing's common all the way through, so let's write our two parentheses, anticipating we can do this. And now what we're going to do is let's look at this leading coefficient of 2. How can we get that? And then that constant, following constant of 5. Well, fortunately, these numbers are prime, so there's only one way to get each one of them. The 2 we can get only with a 2 and a 1, and the 5 only with a 5 and a 1. So let's try this. Let's take the 2 and the 1. Let's put the 2c here and the 1c here. And now the decision that we have to make is, with the 5 and the 1, where are we going to put the 5, where are we going to put the 1? Should we put the 5 here, or should we put it over here? Well, let's just try to make some good guesses. We know we're trying to get to 11. So I'm thinking if I put the 5 here and the outer product, that'd give me a 10. That's pretty close to 11. So I think I'm going to try that. So I'm going to put the 5 over here. Then I'd have to put the 1 over here. And then what I've got is this. The outer product is 10c. The inner product is 1c. 10 and 1. I can get an 11 out of that. All I have to do is get the sign right now. This is a positive 5. So these two numbers have the same sign, which is that middle plus sign. So let's put a plus here and a plus here. And there, we claim, is our factored form. Number 29. Let's factor this, if we can. Nothing's common all the way through, right? 12, 11, and 15. No number common there. We've got W's, W's, no W's here. So nothing common. Let's write our two sets of parentheses, anticipating we can do this. And now, this leading coefficient of 12, here's how we can get a 12, right? Quite a few ways. 12 and 1, 6 and 2, 4 and 3. And then this 15, that constant, we can get a 15 two ways, I can see. 15 and 1, 5 and 3. Now, this is the method of good guesses, and so what I'm going to do here is I'm going to make this guess first of all. I mean, which one of these should I use for the 12? Which pair? I'm going to start with the pair that's closest together. Not that it'll work, but I found more times it does work than it doesn't. So I'm going to go with the 4 and the 3. So I'm going to try here a 4W, right, because we have a W, and a 3W. And now, to get this 15, I could use the 15 and 1 or the 5 and 3. Now, I'm going to go with the 5 and the 3. Now, here's a good guess I can make. The question is, where do I put the 5 and where do I put the 3? I know this. I cannot put the 3 here. I know I'm not going to do that. Now, if I put the 3 here, there would be 3's in common with these two terms. But back here, in the original, there is no number in common. I can't suddenly have something come up in common. So because nothing's common here, I can't have anything common here. So no way can the 3 go here. So I know, by a good guess, an educated guess, that the 3 has to go over here. So let's put that over here. The 3 is going to go here, then the 5 would have to go here, and let's just check if this could possibly work. There's our 12W squared. There's our 15. Let's check to see if we can get the 11. Here's 20. Here's 9. 20 and 9, I can get an 11 if I get the signs right. This 15 is negative. So these two numbers have opposite signs. I'll put that middle plus sign with the bigger product. And the way I wrote mine, the outer product is 20. Inner product's only 9. So I'm going to put that plus sign out here, right? That'll connect me with the 20. If I put it here, I'll get plus 5 times plus 4 is 20. And then I'll put the minus sign here, giving me 20 minus 9 is the 11. And then we will have the correct factored form. Well, while we're here, let's just do another one. I wasn't originally going to do number 31, but let's give it a try. We're going to try to factor this trinomial, nothing in common. So let's set up our parentheses, anticipating we can do this. Now, what about this leading 6? This leading 6 here, I can get with, see if I can actually get it. This 6 I can get with a 6 and a 1, a 3 and a 2. And then we've got another 6 here at the end, that third term. So that All right, that's 6 I can get with. A 6 and a 1, also a 3 and a 2. Now, what am I going to do here? Am I going to go with the 6 and 1s and 3s and 2s? Now, I would try the 3 and the 2 first of all because they're closest together. So here's what I'm going to try first. I'm going to try the 3R and the 2R. And then, so if I go with the 3 and the 2, now just like we did in the last problem, I know the 3 cannot go here because there would be 3's in common. The 2 cannot go here because there would be 2's in common. So the only way this is going to work is for the 3 to go here and the 2 to go here. So let's try that and see if we've got a chance at it here. So if I put the 3 over here and the 2 over here, before I do anything else, let's just see if it's possible, if we get that middle term. Here's a 9, here's a 4. 9 and a 4, I can get a 13 if I add them together. The 6 is positive, so these two numbers have the same sign, which is that middle negative sign. So I'll put a minus sign here and a minus sign here. And let's just run a quick check. This gives us 6r squared right there, negative 9r, minus 4r, negative 13r, negative 2 times negative 3 is positive 6. So we've got it. Method of good guesses.